Last week we looked at the study that was done with 10-month-old infants at Yale University, where the infants were shown puppet shows, sometimes where there was a helper puppet and sometimes where there was a Hinderer puppet, and then the infants were asked which one they preferred. And 14 times out of 16 trials, the infants chose the helper shape. So the question is, how likely is it to get results this extreme or more extreme by chance alone? We're going to use Fathom to help us answer this question. So first, I'm going to drag an empty collection off the shelf, an empty table, and I'm going to create an attribute here that I'm going to call shape. And there was two options for the shape that the baby could choose, helper or Hinderer. And then what I'm going to do is I'm going to sample from this collection. And you might be wondering what actually happened here. Let me show you what we've got in our case table here. So you'll notice that we sampled 10 cases, and if we click on the case tab, we can see that the word helper or Hinderer is showing up each of 10 different times. And we don't want 10 cases, we actually want 16 because we did this trial 16 times. I'm going to turn the animation off for now because if we do this many times, the animation might make this take a little longer than we really want it to. And I'm going to replace what's already in there. I don't want the 10 cases that are in there. I'm going to replace those 10 cases with 16 new cases. And this with replacement basically means I need to allow the helper or the Hinderer, each of those attributes, to be in that bag. So imagine, if you will, for a moment, that you have a bag with just 2 words in it, and the babies were just going to randomly pick out that word. Well, if one baby chose helper, we'd want to put that word back in the bag for the next infant to be able to choose a helper. So that's what with replacement means there. We want the probability of randomly selecting one of these 2 words to be 50% each and every time. So I'm going to do sample more cases. And now notice we have 16 cases, and we could go through and keep track of this ourselves, but instead I'm going to have Fathom do that for us by creating a measure called count. And over here I'm going to type the formula count. I want to count the number of times that our attribute, which was shape, and notice this turned pink. That indicates that we've chosen or typed in a word that the computer recognizes, that Fathom recognizes. We want to know the number of times the shape was the helper shape. And I say OK. And notice we have 6 times where the helper shape was chosen. And if I went back here and counted how many times the helper shape was chosen, that should be 6 times. There's 1, 2, 3, 4, 5, and then 6. So that is correct. All right, so now what we're going to do is do this many times. So here's what we're going to do. We're going to collect measures. And notice we have 5 measures, and you might be saying, well, what are in those 5 measures? Let's see. So here, notice I've got a count of 8, and then a count of 5, and a count of 9, and a count of 8. So this is indicating how many times in a group of 16 trials we have the helper shape selected. So let's actually create a graph for this. We'll create a graph called a dot plot. So I'm going to drag an empty graph off the shelf, put the attribute count on the horizontal axis, and then I'm going to collect another 95 measures. And I'm going to turn the animation off. So here we can see that this happened 1 time out of 100 trials. So if something happens 1 time out of 100, is it likely to happen by chance alone? I would say the answer to that is probably not. In the world of statistics, we call these results statistically significant.